Hey everyone, this is Aaron, and I'm here today to talk to you about moving mic measurements. A moving mic measurement is a lot what it sounds like, taking a microphone and moving it and getting measurements. What this applies to, though, is RTA, which is real-time analysis, and you would do this for the purpose of EQing a response of your speaker system in your home or in your car system. Normally when people measure the response at their seated position, they'll do so with a single mic measurement only, pointed at the speaker system, and they'll record the response playing pink noise or something along those lines. The issue with that, however, is if you were to move a little bit off from where you had the microphone, the response above a certain frequency would shift. And what I mean by that is, if you take speed of sound, which is 13,500 hertz, inches per second, not hertz, and then you take a distance, let's say ear to ear, that's about 6 inches on most people, at least, unless you're like an alien or something, that, or Sloth maybe from the Goonies, and you were to take then that distance into speed of sound, you would come out with about 2.25 kilohertz. Now, what that means is if you were to shift your head 6 inches from where you recorded the response and then made EQ adjustments, everything above 2250 hertz would practically be invalid. You're going to say, I wouldn't move my head that much. Maybe an inch and a half, right? Well, let's say an inch and a half. Now, some of you super smart gee whiz guys can do that in your head. That is 9,000 hertz. My handwriting is sloppy, but you get the point. So it's not the exact frequency that matters. It's what happens as that microphone is positioned differently in measurements, or as you may shift your body weight from side to side. For a good while, what people have been doing as an alternative to the single mic measurement is to take the microphone and measure either at different locations and average them together, or they'll sit in the seated position, hold the microphone up or forward, and they'll wave it around from side to side, starting at one ear or another, starting at their nose, whatever. Point being that they'll move it around to a space. Now this version right here is a moving mic method. The previous version, where you take each one and then average them together mathematically with something like Room EQ Wizard or the like, is a spatial average. Kind of the same thing, but the issue with either way you go is that, first off, let's say you're doing the averaging, you're not quite getting the number of data points that you would really want to get. And by that I mean, let's say you take 6 averages, 1 high, 1 low, and then you do it left, center, right. So 1, 2, 3, 4, 5, 6, and then you average them together. Well, you're missing some of the points in between, right? Almost like an infinite number, not literally, but you see where I'm going with this, right? Or when you sit in the seat and you're measuring around, well, now your body is influencing the response. Both of these are decent alternatives to the single mic measurement. However, they also have their issues. The issue with doing measurements in space and then averaging them together is the response is only as accurate as the number of data points that you measure and then average together. So instead of having an infinite number or a quasi-infinite number of measurements, you have a select few. Let's say most people will do 1, 2, 3, 4, 5, 6, and it may not be in this small window, they may do a larger window. Once you average those together, the data is only as good as each individual points. You're missing points in between. Now, the moving microphone method aims to fix that. The problem, however, is that in order to move the microphone, you're going to have to sit in the car and move it around yourself. Most people would have to do that. I have seen some, and specifically Mark Eldridge, will come up with ways to set up a moving microphone, and that way they can do the response measurements and adjustments via EQ outside of their car or outside of that typical seated position in their home system and that's great. The issue with me doing that is I don't have a lot of time to come up with ingenious ways to do that, nor do I have a lot of money I can throw at this kind of problem. So what I wanted to do was find a solution that was, number one, easy, number two, cheap. Enter the $15 fan from Walmart. So what are you going to need for this project? Well, first of all, you're going to need a fan. I suggest getting this one. It is a Mainstays 12-inch table fan. It is an oscillating fan, which is super important that you get an oscillating fan, otherwise it defeats the entire purpose of this project. This particular one came from Walmart. I paid about $15 for it, and it was on sale from $21. Amazon also offers an alternative. I believe their price is about $20 as well, or maybe $15. But I'll link both in the comments section below. That way you can find either one that you're looking for. If you can't find either of the two that I link, or you simply want to try to source your own just because, what you need to make sure you do is you get one that has a very stable base and a strong motor with it. And you also need to make sure that it's quiet. I spent a lot of time and not a lot of money, but a decent bit searching for the right fan for this project. And that's where I landed at this. I wanted it to be cheap enough to afford and source locally to where you can just run out and buy it today if you wanted to and not drop a whole lot of money. The other things that you'll need are a Phillips screwdriver to help disassemble the fan. You'll need a wooden dowel, which will act as your mic holder. And this is 0.625 inches in outer diameter. I picked this up, I believe, at Home Depot. You can buy them at Lowe's. You can probably buy them at a hobby or craft store. And the reason I chose the 0.625 diameter version is because you'll also need to mount your microphone holder on top of this stick, right? Like so. Now what I did in order to do that is I sanded down the top portion of this just using a wooden rasp, or not a wooden rasp, a metal rasp for wood. If you don't have one of these, you can seriously just take this out with a knife, shave off some edges, then ground it around on the ground and get to where you need to get. Again, the only purpose of that is to affix the microphone holder to the top of it. And once you do that, you may want to wrap it in some tape or something like that. Let's see. The other thing you'll want is you'll either need like vice grips or channel locks or something along those lines, and you'll need that so you can clamp down these guys. You'll need two of these, actually. Little clamps. They're conduit pipe fitting holders. Some people call them C-clamps. There's a lot of different names for these, but I'll link the exact product that I'm using here in my comments. These are 1/2 inch diameter, and you'll need as well either washers like these if you have them around. I would actually suggest using lock washers, and that will hold these into place of the motor or onto the motor. And obviously you're going to need a microphone. But as far as what you need to buy, that's probably going to be it. Just this big dude, relatively big dude, a dowel, and make sure you get one that's long enough. I would say this is about 20 inches. I would probably get a 3-foot one, and then you can cut it to length depending on the height of your ceiling in your car. And then you'll need these clamps, and you'll need some washers. And finally, this is optional, but I would suggest it. Find some foam somewhere if you're out and if you're at Walmart to pick this thing up. Go get some cheap foam. I mean, I wouldn't spend a lot of money, but what I'm using is just some foam I had laying around. What this is going to do is it's going to sit in between your little stand and the motor of the fan, and it's going to help quiet it a little bit. And then this portion that I cut this other piece out of is what the fan itself sits on in the car seat, so I don't potentially scrape it or catch something or snag it or something along those lines. So again, it's optional. You're not going to have it, but I would go ahead and pick it up if you can. Once you've gotten your fan home and you've taken everything out of the box, what you'll wind up with is this portion, which is the base and the motor together. And then you'll wind up some of these other pieces. The base, well, this is the real base, I guess. It's the stand sits on, and the fan blade and the grill and some of these other oddball pieces. that you need if you were actually going to use this as they intend, which is to be used as a fin. And we're not going to do that. So all you really need is this plastic bottom base piece and this dude. Take these, toss them to the side. Once you've gotten all the other stuff taken care of, what you can do is you can start disassembling this guy. Now, this protective piece just slides right off. Then you're left with this little nut. Twist them off. Then you're left with this housing. Now, there's normally 4 screws in here. I've already taken this apart once. I didn't want to put all 4 back in just for the heck of it. So I just left 2 in. I'm going to unscrew those 2. And let me see if I can find my other tools. Make life easy on me. Magic. Now I'm going to take this guy apart. And, you know, normally you're not supposed to use power tools for everything. But I value my time and my sanity more than I do threaded screw holes. So I'm using power tools. And I just drop one. Great. Another tidbit, if you've got a magnetic screw holder, use that. I've got one, but it's full of stuff and it'd be harder to find them than if I just drop them on the floor. All right, so you're taking that off, this piece off. I'll throw that over here. Hang on to the screws because you'll need at least 2 of those. Then you're left with this little wiggle wobble thing. And in order to take him off, the main portion, the main concern here is making sure that you slip the hole up over the piece that makes this thing oscillate. And you'll have to fiddle around with it, but if you just push it from the bottom, tilt it up, it'll slide right over, no big deal. And I'll throw him down here too. You got the inner workings of the motor. Let me go ahead and just say, because I don't want anybody to be crazy, when you're using this stuff and you got this plugged in, don't be a bonehead and start touching wires, okay? I don't have enough money to cover insurance for that kind of silliness, so operate with caution and use some common sense, right? But I will say, I actually took this whole thing apart to try to see if there was a way to quieten down this motor. There's not. And with that said, it's really actually quiet to begin with. I did a little study on that. I'll try to remember to throw in some proof on what I mean here.
And here's proof. What you're seeing here is the measurement in my car system using pseudo pink noise with the motor turned on and the motor turned off. The delta between those 2 measurements is about plus or minus 1/2 dB. To put that into context, I can guarantee you without a doubt that if you were to sit and wave the mic around in front of your face, that your accuracy would be lower for sure than 1/2 dB. Carrying on.
Once I turn this on, and I'll go ahead and do that now. I had it right the first time. Ain't that life? All right, so I'm gonna be quiet. Okay, really quiet. Now I'm gonna turn this on. Now you may think, oh dude, that sounds loud, but once you get in the car and you actually play pink noise at anything more than talking volume, like for example, I'm going to keep talking and you can hear all this is almost drowned out. Now my impression of pink noise. See how it drowns it out? Okay, turn it back off. Unplug it when I'm messing with this thing. This is the part where you'll want your little foam piece. Now the foam piece, the purpose of this guy right here is, seeing here is where the internal workings of the motor are, and in this area, these little outlets is where you can hear some extra noise. Now you can silence that just taking a piece of foam. I would get something that won't get sucked up inside of there. Don't get, you know, fiberglass, because eventually you'll get sucked up inside of there and eat this thing up and mess it up, and you'll have a whole different set of problems. So get some kind of foam that's sturdy for this portion. And again, you don't have to have it. I'm not sure that it makes a big enough difference to bother with, but that's what I would suggest. And now you will take your little clamps and a washer, and you'll take one of the original screws that you had taken off of this previously. All right, I made little holes, little pass-through holes in this piece of foam, and you can't really see it because I can barely see it with my eyes and I'm standing right next to it. But you can trust me, So with these little pass-through holes, I slip the screws through. See the top of that screw there, and then that will go in that threaded spot. Now, if you use thick foam like I've got here, it's going to be a little bit tougher, but you'll get there eventually. That's why I suggest, a 1/4 inch thick foam will be plenty. I wouldn't go any thicker than 1/2 inch though, because you'll probably never get this piece put back together. And let's see, this is going to be the fun part where I have to go, where's the hole, man? Where's the hole, man? There it is. Found you. And again, just screw it into place. I wouldn't tighten these up all the way just yet, because you're going to need to be able to put your dowel rod through. And then this is the part where the dowel rod goes through. Now, I've already bent these little clamps out of the way when I was using this previously. At this point, you'll have to do that, and then that's where the little channel locks or vice grips or whatever you're planning on using will come in handy. Slide underneath, twist them out of the way. I put this dowel in through these clamps, and I used these guys to help squeeze it and hold it into place. Now, the one thing that you want to be careful of is that your dowel doesn't extend past this point, past the housing, because if you do and you turn this guy on, he'll wind up rubbing here, and you could possibly damage your motor if it winds up getting stuck like that for a while and you're outside of your listening position. You're not able to hear it or notice it. So now that I've done that, I'm going to turn it on. And you can see that it moves. And again, I know it sounds loud in the video, but once you get it in your seated position and you turn up some peak noise at any kind of realistic volume, it'll be more than fine. You can actually hardly hear it over my talking, and this is just my normal, not trying to be loud voice. Now, if I were trying to be loud, I would do like this, and I would sing, but I do not have a microphone. Hold on, I'll fix it. La da 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 da, microphone. All right, so that's kind of it for putting this guy together, except for obviously you do want to put the mic holder into the dowel again where you had sanded it down at the top, right? Remember you did that? Or you use some kind of fancy boom mic with the threads on it and you can just thread it on. Before you put it in your seated position, your car, your chair, whatever, I'd advise going ahead and put this guy on just in case. Unplug it. And now we are done, and we're going to take it to start measuring. Once you've built your contraption and got it ready to go, here are a couple pointers. For one, if you're using this in a car, this cord, when you close the car door, make sure to not pinch it to where it would short out. Lay it against the gasket that runs along your car door. Another thing is the base being optional. I chose to keep it on because it provides some extra support. You can wedge the base between the seat back cushion and the seat bottom cushion, and it'll slip back a little bit further. Also, the microphone, depending on where you want it in the seated space, you may have to take your headrest off. You may also have to tilt this one way or another. Additionally, you can point the mic upwards and let it rotate in space this way. This is where the customization of the rod length will come into play. One concern you may have is any reflections coming from the contraption itself. To help against that, what you could do is you could set this up in your back seat or in the floor if you're in a home theater or something like that, and use a different rod, or you can use maybe a set of L brackets or something to extend, make an L shape out of this guy, and extend the microphone out into the seated position, and then let it rotate freely behind the chair that you're actually sitting in. That way you wouldn't have any effects of this guy. You can also rotate the microphone upwards and use it on the boom. And when you do these kind of things, make sure to test the rod length out first before you cut it. And like I said in my earlier portion,
Mine is measured at about 20 inches. After messing around with this a little bit more the past couple days, I think what I'll probably wind up doing is cutting it down. Or I may do, like I said previously, and try to rig up a way for it to set in the back seat. If you were to use it in a car and you needed it to rest on the headrest area, you could maybe even buy something like a sealed bearing and run a rod through a sealed bearing. That way it rotates along the sealed bearing and it has a support from the headrest area. It's just an idea. I'm sure that a lot of you ingenious folks will come up with some really clever ways to I guess, improve upon this. Be my guest, and if you do, feel free to let me know, and feel free to let the rest of the community know as well.
Some of my comments about how to use this thing in a car still apply to a home stereo or a home theater setting. Obviously, however, you don't have to worry about getting the cable smashed by your car door. Another suggestion I have about using this is make sure you keep in mind where this guy is going to be at in your seated position. So in my chair here, he's actually a little bit forward of where I'm sitting. Now, if I were to lean this chair back a little bit or even scoot this guy back a little bit, what that would do is that would put the mic closer to where my head area would be. And I will say that the good thing about this, even though it might be a little bit forward of my head area at a normal angle, let me do this. There we go. It's still not any worse than if I were sitting here and waving the mic in front of my face. Actually, if I take my hand and move it to there, the mic is at the exact same point it would be. So there's really no big loss there if you don't get it perfect. But ideally, if you're going to go through this trouble, you want to get it as good as you can. So having said that, you can either do like I said and scoot this thing or lean it back. Or the alternative is to set this behind the seat back here. And then you would let it run, something like that, but you would need a different size pole. Matter of fact, it may even be useful to buy you a couple dowel rods while you're at the hardware store or wherever you get these from, because cheap as they are, it would be a good idea maybe to have a few on hand of various length. Now, if we turn the motor on, and just listen, it's not super quiet, but it's quiet enough. Once you start playing pink noise or whatever it is that you use to generate the noise for your measurements, certainly that noise will outweigh the noise of this motor. Ideally, this guy would be Willy Wonka's glass elevator. He wouldn't just go sideways. He would go up and down, slant ways and crossways and every ways that you can imagine. And the reason for that is it would then encompass a head area rather than just a portion of the head area. But still, with that said, I believe that using this kind of method is better than sitting in a car and having your body's influence, or sitting outside and only being able to pick certain points and then averaging them together. Alternatively, what you could do if you were so inclined would be to measure your response at a typical ear height using this, then lower the mic and do it at chin level, and then raise the mic and do it at the top of your head level. That way you get 3 different areas, and with each one of those results, what you can do after you measure, save that result, and then average them all together. Now that's not a whole lot different than doing a spatial average with 6 mics in location, but the good thing is that you have multiple steps along the way. One thing you may ask is, do you need to average with these measurements? And by average, what I mean is REW has the ability to take points and incrementally average them together in real time. The answer is probably not. The idea here is that this guy in real time is doing the averaging for you as it sweeps through your headspace. Now, truthfully, I haven't really played with the difference in those measurements, but to me, the downside of doing that is in order to do that, you have to hit a stopping point. So let's say you take 32 averages in REW. When you hit that average, then it's done. There's no more. So if you're trying to play with your EQ and make adjustments in real time, well, that average is still going, but none of the measurements are part of that average anymore. So I would just say, don't worry about averaging. Let this guy do the averaging for you. And that concludes the portion of how to use this in your car or your home. To wrap everything up, what we've done here today is we built a moving microphone measurement method out of a cheap fan from Walmart and some cheap supplies found at your local hardware store. This benefits you because you are no longer taking just a single point measurement, nor are you taking multiple measurements and averaging them. And I'll tell you one thing that beats is if you were to do any of these kind of methods that we discussed before, such as single microphone, multi-microphone and average, or the sweep across your face while you're sitting in the seated position, every time that you do that, you have to pause the measurement and make adjustments on your laptop or your DSP software, and then go back to that measurement process again. This really beats the multi-microphone and then average, because you're probably never going to get the exact same points unless you build a rig for it. And then you have to stop and start your measurement and your EQ process over and over multiple times. And this also beats sitting in the listening position, waving the mic around, because if you're trying to hit a target curve, I can guarantee you 100% that that target curve does not include the influence of your big old body and your torso and your big noggin and your nose, right? There's no way. Nobody has built a target curve for that. That's why this method works better than those other methods, because it's taking multiple points in space and putting them into something that you can trust and you can use in real time while standing outside of that listening position, not having your body influence it, and make the adjustments. And with all that said, no method is really perfect. This is really, in my opinion, probably the best you're going to get for a realistic budget. Ideally, like I said earlier, you would have something that would sweep a whole head area and not just do back and forth. It would do up and down, side to side, all of that. But you're going to have to spend some time and some money to do something like that. And finally, I'm here to help. I hope this has been useful. If you like what you see, do me a favor, hit the thumbs up button, subscribe to the page. There's also a notification I guess you can hit. And the reason that helps me is eventually if I get enough followers and subscribers, then I can start doing some ad generated type things. And I'm probably not going to make more than a few bucks a month, but any of that money will help go toward me paying for these materials that I bought, for instance, this weekend, to build this kind of stuff and to help you guys out. I really enjoy and love doing this. I love learning. I love tinkering, but I don't have an unlimited budget. So, the donations I get from you guys, I really appreciate that. And that helps to go a long way toward improving the content that I'm able to provide you as well. I hope you all enjoyed it, and leave a comment. If you have any questions, I'll do my best to answer them. You can find me on my Facebook group page, or you can give me a shout, because I see a lot of you guys out at various shows. Come up to me and talk to me and ask me whatever questions you got. If I can't answer it, I'll definitely try my best to find you somebody who can. Thanks for watching. Appreciate it.